Here we are taking the one problem for extension of the binomial theorem. We are applying the binomial theorem. First we can check, is it suitable for binomial distribution or not. The first problem is, out of 800 families with 5 children each, how many would you expect to have 3 boys in the first case, 5 girls in the second case, third one either 2 or 3 boys, fourth one is at least 1 boy. Assume equal probabilities for boys and girls. In general, in a family, either boy or girl. So, the probability of boy is equal to 1 by 2. Why? Because the distinct numbers are 2, boy or girl. The probability of girl is equal to 1 by 2. So, they have given assume equal probabilities for boys and girls. First, here we can take the probability of each boy. The probability of each boy, that is equal to 1 by 2. Since equal probability for boys and girls, that is nothing but 1 by 2. Okay. Here, number of families is equal to 800. But we can take the number of children in each family. So, we are discussing about the children. So, number of children, let it be small n is equal to 5. Okay. In the first case, probability of getting three boys, that is equal to P of x is equal to 3. It is equal to, by using of the binomial theorem, why? Because it is the divided into 2 cases, one is boy and girl. So when it is either success or failure case, we are going to apply the binomial distribution. By the binomial distribution, that can be defined by b of x such that n comma p is equal to ncx p power x q power n minus x for x equal to 0, 1, 2, 3, 4, 5. Why? Because 5 children. In that, boy means no boy, 1 boy, 2 boy, 3 boy, 4 boy, 5 boy. So, here probability of x equal to 3 is equal to n is 5, 5c3 p power 3, that is 1 by 2 whole power 3, q power n minus 3, 5 minus 3. It is equal to 5c3 is 5 factorial by 3 factorial into 2 factorial. It is 5c3. That is 5 into 4 by 2, 2 ones are 2 twos are 5 twos are 10 into 1 by 2 whole power 5. Why? Because bases are same, then we can add the powers, then it will be 5. It is equal to 10 by 2 power 5. Simply we can write it as 10 can be written as 2 5s are 1 2 get cancelled. That is 5 by 2 2s are 4, 4 4s are 16. 5 by 16. It is equal to probability of getting 3 boys. But we can discuss for 800 families. Expected of 3 boys for 800 families. is equal to 5 by 16 into 800. 16 ones are 16 fives are 80, 0, 5 fives are 25. 25, sorry, 250. 5 zeros are 0, 5 fives are 25. So 250 families. Therefore, 3 boys are expected in 250 families. This is the first solution. Second condition, probability of getting either 2 or 3 boys. Either 2 or 3 boys means we can take probability of x equal to 2 plus probability of x equal to 3. That is nothing but P of x equal to 2 or x equal to 3. That is equal to probability of x equal to 2 plus probability of x equal to 3. We can take 5c2 p power 2 q power 5 minus 2 is 3 plus 5c3 p power 3 q power 5 minus 3 is 2. We know that 5c2 is equal to 5 factorial by 2 factorial into 3 factorial. It is also 10 only. 5c3 value is 10, 5c2 value is also 10. It is equal to 10 into 1 by 2 whole power 5 plus 10 into 1 by 2 whole power 5. It is equal to 1 by 2 whole power 5 is taking common. 10 plus 10 is 20. 20 by 2 power 5. 2 into 2 into 2 into 2 into 2. 2 ones are 2 tens are. 2 ones are 2 fives are. So probability of x equal to 2 or x equal to 3 is equal to 5 by 2 to the 4, 4 to the 8. So expected families or expected of 2 or 3 boys for 800 families is equal to 5 by 8 into 800. 8 ones are 800. That is equal to 500. Therefore, we are expecting 2 or 3 boys in 500 families. It is the second question. Third one is either 2 or 3 boys. Second one is 5 girls. It is third one. Second one is 5 girls. Expecting of 5 girls means probability of no boy. That is equal to P of x equal to 0. Equal to 5c naught 1 by 2 whole power 0, 1 by 2 whole power 5. 5c naught is 1, 1 into 2 power 5, it is equal to 1 by 2 to the 4, 16 to the 32. So expected of no boy for 800 families is equal to 1 by 32 into 800. 16 twos are 16 fifties are 2 ones are 2 25s are. It is equal to 25 families. Therefore, no boy can expect in 25 families. Fourth one, D. D is at least one boy. Probability of at least one boy. At least one boy means that is equal to 1 or greater than 1. Minimum one boy means it is 1, 2, 3, 4, 5 or possibilities are there. So at least one boy means we can write it as 1 minus probability of x is less than 1. Probability of x is less than 1 means probability of x equal to 0. Already in the above, 1 minus 1 by 32. Probability of no boy means 1 by 32. So it is equal to 32 minus 1 by 32 equal to 31 by 32. So expecting of at least one boy for 800 families is equal to 31 by 32 into 25. 25 ones are 25, 2 is the carry, 25 threes are 75 plus 2, 77. 775 families. It is the solution of the given question. Is the 1 by 32 is 25, it is 800. For 800 families means 30. 2 ones are 30 to 25s are. So 25 ones are 25, 2 is the carry, 25 threes are 75 plus 2, 775. Already I did here 1 by 32 is 25. So 25 is multiplied with 31. Then we are getting the expected of one boy for 500 families. Okay. Second question is 20 percentage of items are produced in a factory or defective. Find the probability that in a sample of 5 chosen at random, that is nothing but n is equal to 5, the probability of the defective items equal to 20 percentage, that is nothing but 0.2. And the probability of good ones is 1 minus 0.2 is 0.8, that is not defective items. Here they are asking about none is defective means probability of x equal to 0. 1 is defective means probability of x equal to 1. And the third one is probability of 1 is less than x is less than 4 means 2 defective, 3 defective will come in the third case. Okay. First of all, we can taking what they have given. The probability of defective items. The defective items equal to small p equal to 20 percentage, that is equal to 0.2, or 20 by 100, that is 0.20. And the probability of non-defective items. Non-defective items means we can taking the relation q equal to 1 minus p it is equal to 1 minus 0.2 equal to 0.8. 0.20 means 0.2 only. Here we know the P and Q values. Next we can take number of items or number of samples equal to 5, that is equal to small n. In the first case, the probability of none is defective. That is nothing but P of x equal to 0. Here, in this defective, non-defective, only two cases are there. In that we are using the binomial distribution. Since the binomial distribution can be defined as B of x such that n comma p is equal to ncx p power x q power n minus x for x equal to 0, 1, 2, 3, 4, 5. Why? Because we are taking 5 samples. In this, probability of x equal to 0 means 5c naught p power 0 q power 5 minus 0, p equal to 0.2 whole power 0, q is 0.8 whole power 5 minus 0 is 5. It is equal to 5c naught is 1, 0.2 whole power 0 is 1, 0.8 whole power 5. It is equal to 0.8 whole power 5. After the calculation, we are getting the value is 0.32768. This is the probability of x equal to 0, that is the non-defective is 0.32768. The second one is defective. Second case is the probability of getting 1 is defective. 1 is defective means we are taking probability of x equal to 1. It is equal to 5c1 0.2 whole power 1, 0.8, 5 minus 1 is equal to 4. We know that 5c1 value is 5 into 0.2 into 0.8. 5 to the 10, that is 1.0 into 0.8 whole power 4. After the calculation of the decimals, we are getting 0.4096. Therefore, probability of one defective is equal to 0.4096. Third case is probability of 1 is less than x is less than 4. That is equal to probability of x equal to 2 plus probability of x equal to 3. In between of 1 and 4, the two values are there. Those are 2 and 3. Next, again, we can apply the probability of the binomial distribution, that is 5c2 0.2 whole square 0.8 whole cube plus 5c3 0.2 whole cube 0.8 whole square. We know that 5c2 equal to 5c3 equal to 10. Already we did in the previous problem. It is equal to 10 into 0.04 into 8 8 is 64, 64 8 is 8 to 8 4 is 32, 3 8 6 is 48, 51, 0.512 plus 5c3 is the value 10, 0.2 whole cube is 0.008, 0.6 whole square is 0.64. Here 10 means 0.4 into 0.512 plus 0.84. This decimal is come to shifted to the right side. 0.08 into 0.64. After the simplification, we are getting 0.256. 4 2s are 8, 4 1s are 4, 4 5s are 20. 8 4s are 32, 3, 8 6 are 48, 50, 51. 1 2 3 4. So 0. Therefore, probability of 1 is less than x is less than 4 is equal to 0.256 is the value.